Hey everyone, welcome to Building Trades Maintenance. This is a safety presentation and I am your instructor, Stephen Ray. First thing we're going to talk about is conduct on the job. Respect. Respect is a huge thing, right? My attitude will always be based on how you treat me. If you're disrespectful, then that's what you're going to get. No horseplay, no screwing around, no chasing people, nothing like that in the lab. Simply unacceptable. No distractions. If you look at the center picture that we have here, this fine gentleman is on his cell phone. He can't tell what's going on in front of him, behind him, or next to him. Unacceptable in the lab. Some general safety rules. So it pays to have knowledge of what you're doing, have some skill, and have an attitude of care and concern. Always dress for safety, not for style. That means no loose fitting clothing, no jewelry that can get caught, and if you have long hair, either on your head or on your face, make sure that it's tied back out of the way. Some general safety rules. So let's take a look at some of these. This guy right here is on the cliff face using a jackhammer, which obviously we can all agree that's not good. On this one here, this fine gentleman is using a circular saw to cut a piece of wood going up the other man's back. Again, not acceptable. We're trying to cut wood, not spines. And if you look at the other examples, they're just as bad. To avoid some hazards, we use personal protective equipment such as safety glasses. The reason we use safety glasses is because we use power tools, and the power tools can throw particles much faster than what you can by hand. Gloves, again, these are to protect from minor scrapes, cuts, vibrations, stuff like that. Keep in mind that they will not protect you from a blade that's moving or a bit that's rotating. Earplugs or earmuffs. In this lab, we use earmuffs. They help prevent temporary hearing loss after work. And you can tell when hearing protection is needed because you will have ringing or humming in your ears after you leave work, or in this case, the lab. If you need to shout so a coworker that's 3 feet away from you, or if you go one arm distance away, if that's the case and you can't hear them speak in a normal volume, then you need hearing protection. Respirators, when they're needed in the lab, you will be provided, and those protect from dust, vapors, and other particulate matter. Here's another example of exactly what not to do. You can see this gentleman has no glasses, no earmuffs, no gloves. Some general safety rules. So we want to talk about building permits, especially in the context of this lab. Why do you need building permits? If you have a building permit, that means that the township, municipality, or wherever you're at comes in and needs to inspect what you're doing to make sure that it adheres to codes, building codes. That ensures that the people who are going to live there or the people who are going to work there are going to be safe. In BTM, we'll get more in depth about this. Generally, it's any time that we need to hide something behind a wall, whether it's wires, pipes, framing, anything like that. If you don't use the permits, there is something called tear out. Let's go back to that. So in this instance, you'd have to tear out the work. So if you went and you did a wall or you did plumbing or electrical work, you'd have to tear it all out. The inspector would have to see what you did. Some general safe practices in the lab. Use the right tool for the right job, right? I don't want to see you drive nails with a wrench. Make sure there's adequate lighting. So if you need to turn the lights on, turn the lights on. You need to see what you're doing. Make sure that the work area is free of debris and spills. It's a slip hazard, right? Clean it up. Use only manufacturer-approved attachments and accessories. I don't want to see you guys doing custom mods on any of the tools here. It's unnecessary. Use the tool the way it's supposed to be used. If you can't, let me know. Maintain your balance and don't overreach. This is important, especially when working on an elevated surface. Maintain control of the tool by using both hands, if permissible, and a tight grip. So don't try to hold stuff with one hand if you don't need to. And good housekeeping is very important, always keeping a nice clean area. This is a video on lifting technique. I'll allow you guys to watch this on your own. And it goes through these 8 safe lifting techniques. And we'll go over these in class, so just take a quick look at them. They're also addressed in the previous video. Here we're going to go over some safe ladder practices, so you can see this guy is just clowning around, right? No good. He's already ready to fall. On this one, this is the wrong type of ladder, and the way that it's supported is very unsafe. Again, on this example, wrong type of ladder. He's using an extension ladder when he can be using an A-frame instead of using someone as a support right here. On this one, definitely the wrong thing to do, working on steps. And here we have this person working on the very top step, which the ladder manufacturer tells you don't do it, so don't. Always inspect the ladder before each use. Sometimes they get damaged, sometimes they're cracked, but it's up to you to make sure it's in good working order before using it. Here's another video for you to watch. Again, you can do this on your time. If you have questions about it, let me know. So OSHA ladder safety, always read and follow all labels and markings on the ladder. These are usually on the side of the ladder in the form of a sticker. Always avoid electrical hazards, so before you set up your ladder, look for overhead power lines before setting it. Avoid using a metal ladder near power lines or exposed energized electrical equipment. So we have fiberglass ladders you can use this for that we have in the lab, or if you're out on a site, you can use a wood ladder. Use only ladders and appropriate accessories such as ladder levelers, jacks, or hooks for their design purposes. Again, don't modify them. Ladders must be free of any slippery material on the rungs, steps, or feet. I think this goes without saying. Keep it clean. Do not use a self-supporting ladder, such as a step ladder, as a single ladder or in a partially closed position. We saw this on a few of the previous examples. Do not use a top step or rung of a ladder as a step or rung unless it was designed for that purpose. Again, we saw this in the previous example. Use a ladder only on a stable and level surface unless it has been secured top or bottom to prevent displacement. So in this instance, say like a step, like we saw on an example in the previous slide. Do not place a ladder on boxes, barrels, or other unstable bases to obtain additional height. Again, I think this is common sense. You wouldn't stand on a box, right? So why would you put a ladder on a box? Do not move or shift the ladder while a person or equipment is on the ladder. It's obvious when a person's on there, but sometimes people leave equipment, such as hand tools, up at the top. So before you move a ladder, always check up top and make sure that there's nothing up there that could fall on you or someone else. An extension or straight ladder used to access an elevated surface must extend at least 3 feet above the point of support. There's an easy way to do this, and we'll cover that in lab. A ladder placed in any location where it can be displaced by other work activities must be secured to prevent displacement, or a barricade must be erected to keep traffic away from the ladder. This sounds confusing, but for example, if you're working in a doorway, put up a sign on the other side of the door letting people know, hey, there's someone on the ladder behind the door, so open it slowly or find another way. Be sure that all locks on an extension ladder are properly engaged. If they're not properly engaged, there's a chance of it collapsing. Do not exceed the maximum load rating of a ladder. Be aware of the ladder's load rating and of the weight it is supporting, including the weight of any tools or equipment. This can be found on the label on the side of the ladder. Most of the ladders that we have here are rated for 300 to 350 pounds. So another type of elevated surface, such as a scaffold or anything like that, we need fall protection for. OSHA has a 6-foot rule. So if you're 6 feet above and you're elevated 6 feet, you need fall protection. If you're working over open machinery that's rotating or pulleys or anything like that, you also need fall protection. It makes sense because you don't want to be falling into a pit or anything like that. Some of the fall protection that you can have are in the form of guardrails, safety nets, or personal fall arrest systems. Personal fall arrest systems and the guardrails we have in the lab. One thing also when we're doing the masonry portion of the class is if you're reaching 10 inches below your walking surface, you also need fall protection. So if we have scaffolding set up in the lab and you're laying up a block wall and you have to reach down below the surface that you're walking on by 10 inches, you need fall protection. Fire extinguishers. So there's a few fire extinguisher types. The first one is Class A. Class A's deal with wood, cloth, paper, and rubber. Class B fire extinguishers deal with flammable liquids, combustible liquids, solvents, oil-based paints, and flammable gases. Class C involves energized electrical equipment. So my question to you is, what type do we have in the lab? You can go check. There's 3 in the lab. When you're using a fire extinguisher, always remember this acronym, PASS. First thing you do is pull the pin to the fire extinguisher, aim the nozzle at the base of the fire, squeeze the trigger, and then sweep back and forth. There's 3 located in this lab, so take a minute and find them before you continue. Another safety portion is the safety data sheets. So when you access Clever to get to Schoology, your Clever page is going to look a little different than this, right? I have a lot more stuff. But you'll still have your SDS sheets right here, the SDS Online. And that gives you access to all the chemical hazards that we have in the BTM lab and what to do in case you come in contact with them. Electrical safety. So, do not use power tools in or around water. Do not use power tools with cracked housings. We'll demonstrate this more in the lab. Do not use power tools with frayed cords. If you have a frayed cord, you need to report it to me. Do not use power tools with missing prongs. We're going to look at an example of this later. Do not set ladders against electrical lines. Even if they're fiberglass or wood, do not set them against electrical lines. And always check the general condition of your power tools. If your plug is polarized, it's going to have 2 prongs. And if the piece of equipment is polarized, it must have the double insulated symbol. So look for this. It's 2 squares, one inside the other. If you don't see this, do not use it. If the plug is grounded, which you might be more familiar with, there's 3 prongs. All 3 must be there and in good shape. Sometimes you'll see the bottom grounding one taken off, and it looks like a polarized plug, but it's not meant to operate like that. It won't be double insulated. So make sure that you have your grounding prong. Evacuations for the school. So one of the things that we have is the ALICE procedure. The ALICE procedure deals with active shooters. So ALICE is an acronym, and we'll go through what each letter stands for. A is alert is your first notification of danger. Generally, there's an overhead announcement letting us know if there's an intruder in the building. L is for lockdown or barricade the room. Depending on where we're located, we will either lock down or barricade the room or prepare to evacuate or counter if needed. If we're able to, we follow I, inform, communicate the intruder's location and direction in real time. So if they're in BTM and they're heading towards another lab, we can communicate that with other people. Depending on the location of the intruder, we may have to counter, create noise, movement, distance, and distraction with the intent of reducing the shooter's ability to shoot accurately. If they come into the lab and there's nothing else that we can do, then we can throw stuff at them, desks, chairs, tools, whatever's there. If we're far enough away, we can evacuate. So when it's safe to do so, we can follow the same procedure that we would for a fire drill, more or less. During a fire drill, we have a glass man door in the lab. We will turn right and head towards the wall in lot 1. If I announce clear the room, clear the room. Make room for emergency personnel to access the area. For the phone, if there's an issue and I'm unable to call anybody, dial 0 for the main office and 1325 for the nurse. Further information on different phone numbers is in the emergency guide that's located behind my desk. If you have any questions, please ask. If you need help with anything, please ask. Thank you, and I will see you next time.